Okay, so 1.6 is on functions and how we can take two functions that we have and combine them together to make a new one. We're going to look at some simple ways to combine, like adding, subtracting, multiplying. So like if you had, let's say, f of x equals 2x and g of x is 3x, and I said to you, I want you to find the new function by adding f of x and g of x. Well, the new function would be like y equals 5x. And you can add those together because they're like terms. Now, if they weren't like terms, and I said to add them together, then the new function would just be 2x squared plus 3x. Okay, there's nothing you could do. So we'll do a little bit with adding, subtracting, multiplying, dividing. And then we're going to look at another way we can combine functions together, which is composition. All right, so that's what I just told you we're going to do. Take two functions that exist, and we're going to combine them to make a new one. Oh, I scroll all the way down. And the four basic ways are multiply, add, subtract, multiply, divide. When we add, subtract, or multiply, there's really not too much we have to be careful about. Division, we do have to be careful because you could take two functions that had a domain of all real numbers to start with, and both of these are all real numbers. But if you combine them by dividing them, 2x squared divided by 3x, you just created a fraction. If your fraction could ever have a 0 in the bottom, we need to avoid that. Okay? I think you're pushing in.
No, I was saying like if you were done talking.
Oh yeah, you go ahead. Yeah. Yeah, it's pretty. So dividing is one we do have to be careful with. The goal, once we combine functions together, is going to be to figure out the domain and the range. Range, we usually use the graphing calculator to help us see a picture. Domain, we just try to make sure you never divide by 0 and you never take the square root of a negative number. So those are the two things you have to be careful about with domain. Okay, so here's two functions. And let's combine them together a few different ways. And let's start by adding them. First of all, are f of x and g of x like terms? What do you think? Yeah?
Yes, because they basically mean y equals something. That's what the function of x is.
So like terms would have to mean that you have one that's like a 3x and a 2x. Those would be like terms. Or 8y cubed, 5y cubed. They have to each have the same letters raised to the same powers. Does f of x and g of x have that? No. Like an example of like terms would be x squared and then 4x squared. Okay, they both have to be x squared, or they could both be square roots of x plus 1s. Like if you had square root of x plus 1, and then you had plus 2 square roots of x plus 1, you can say that that is 3 square roots of x plus 1. But they would both have to be square roots of x plus 1, and they're not. So they're not like terms. So when you add f of x to g of x, all you can really do is write down, here's my new formula, and there's nothing we can combine. It's just x squared plus the square root of x minus 1. Sometimes it will combine. Okay? It just depends on the original problem. How about if we divide them? F of x divided by g of x. What function would be in the top? Yep.
X squared.
X squared. And what function would be in the bottom? Square root of x plus 1. And again, that's all we can really do. I'm not worried that we have the square root in the bottom. I know we're not supposed to leave it there. But it's not really what we're getting at with this section. So it's okay. So any questions how we created these two new functions from the two original ones we had? That's combining with addition and division. Okay, and there's more examples on page 58 if you look at the PDF. So now the domain. Well, let's think of the domain this way. Let's say that all of these numbers are the numbers you can plug into f of x. All of these numbers are the numbers you can plug into g of x. The domain is the numbers that you can plug into both. Okay, so it's the numbers that would work in the first one and the second one. So it's the numbers that work in both functions. So the domain of the new function is all your x values such that x works in both of the original functions. Now, that's all you really have to think about if you combine two functions by adding them, subtracting them, or multiplying them. If you divide them, you can create a fraction where you maybe didn't have one. So if you end up creating a fraction, make sure that the denominator would never be 0 when you're describing the domain. If there is a number that would ever make the denominator 0, then you need to tell me that number is not part of the domain. Right, so we're gonna try like one or two examples of that right now.
Less.
And we're not going to have to write this down because I think we've written it quite a few times. We don't want to divide by 0, and we also want to be sure that when you're taking square roots that you don't do what? Yeah?
Take a negative.
Right. We don't want to take a square root of a negative. I had that written down, but I think we've said it so many times now. Just make sure you don't take the square root of a negative number. Can't do that. Okay. Yes?
Is it all even roots that you can't take a negative of, or only square roots?
No. So if you tried to do like the fourth root of negative 16, that would be imaginary. Because the fourth root of 16 is 2. So if you multiply 2 times 2 times 2 times 2, you get 16. So that doesn't work. If you multiply negative 2 times negative 2 times negative 2 times negative 2, that doesn't work. So yeah, that would be an imaginary answer. So yeah, it would be all even roots. Odd roots don't have that problem. You can take an odd root of any number, positive, negative, or 0. It's just even roots you have to be careful with. And we do talk more about that when we study all about roots in general, but that's not till like chapter 4 or 5. 4. I think it's chapter 4. Okay, so here's two functions. And what you always want to do before you combine them, because we don't even know how we're going to combine them yet, just find the domain of the original functions. So at least you know what you're working with to start. And then we'll go from there. Okay, neither one of these has a fraction, so you don't have to worry about dividing by 0 yet. But they have square roots. We don't want to take the square root of a negative. Square root of 0 is perfectly fine. So what numbers could you plug in for x in the top one?
Negative 3.
That's one number you could plug in, negative 3. What would be all the numbers you could plug in? And the way we'll write it as an interval. Tell me the lowest number you could plug in, and then tell me the highest number you could plug in. Yep.
Bracket, negative 3, infinity, parentheses.
Perfect. That basically means x is greater than or equal to negative 3. Some people get tripped up, like, why can you include the negative 3? Absolutely. You can take the square root of 0. That's no problem. You can't divide by 0. I think that's what some people mix up. All right, and then how about for this one? What's the lowest number you could plug in for x, comma, the highest number? Yeah?
Is it 2, comma infinity?
And what kind of symbol on the 2?
Okay.
Yeah, and parentheses. If you're like, well, how come you can't do 1? Well, try 1. 1 minus 2 is a negative number. So the smallest value you can plug in is 2, but then you can pick anything bigger. Okay, so now I want to combine these functions by adding them. Is what's under the root symbol the same? No, then they're not like terms. It's not like you have a square root of x plus 3 and then 5 square roots of x plus 3. So when you add 1 square root of x plus 3 and 5 square roots, you get 6 square roots. They're not like terms. So all you can do is this. Square root of x plus 3 plus the square root of x minus 2. And now the domain is the overlap. It's the numbers that are in this domain and this domain. If you can't see it, think of it on a number line. Okay, the top one is every number from -3. So this is -3. It's every number from -3 going that way forever. The bottom one is every number from 2 going that way forever. So the domain here is the overlap between the two of them. So what do you think the domain would be? Yeah.
Would be 2, comma infinity.
2, comma infinity, and the symbol on the 2.
Oh, right.
Bracket. I just keep putting the parenthesis on the infinity because that's not even a question. It's always a parenthesis. But yeah, the domain here, if you think of it like a Venn diagram, where the overlap is, it's everything from 2 and up. And that's it. Any question on that one? All right, so that's combining them with addition. Let's combine them by dividing. And I'm not worried if we leave a square root in the bottom. I mean, it's not great, but it's okay because it's not the focus right now. But what would go in the top here? The square root of x plus 3. And in the bottom? Square root of x minus 2. So there's the function you get when you divide them. Now I want to know the domain. What do you think the domain would be this time? Yep.
Parentheses 2, comma infinity.
Exactly. Perfect. Why parenthesis on 2 and not a bracket?
Because you can't have 2 at the bottom. You can't have 0 on the bottom.
Can't have 0 in the bottom. So not only do you have to find where the domains overlap, which we did in the last problem, you also can't plug in the number 2 here because 2 minus 2 gives you 0. Square root of 0, that's okay, 0. But the problem is this divided by sign. You can't divide by 0. So that's why the number 2 cannot be plugged into x because it's a fraction this time. Yep.
Does f of x always have to be on the top?
No, it could be g of x divided by f of x. Yep. Yep, could be any order.
What's the difference between the bracket and parentheses again?
Bracket means you can include the number 2. Parenthesis means you cannot include it. So if you did this as like an inequality, it would mean this. Open circle on 2, shade right. Bracket would be closed circle. That's the difference. Okay. Any question on that? So it's a small difference, bracket or parenthesis, but if you put the wrong symbol, it's completely wrong. All right, let's try this one. So it wants me to do f of x divided by g of x. A lot of times I guess it is in alphabetical order, but it definitely does not have to be. So f of x is the absolute value of x, and g of x is x. Let's start with the domain. Do we have any square roots in this one? No. So we don't have to worry about that. Do we have any fractions with letters in the bottom? In this.
Oh, yes.
Yeah. We combine these functions by dividing. So we did end up with a letter in the bottom. So you need to tell me what number you can't use.
0.
You can't use zeros. There's two ways to write it. I need to show you the other way. But this is one way. That's telling me what you can't use. A lot of times when you write domain, they want you to write what you can use. So think of it as a number line. You can't pick 0. Can you pick anything lower than 0? Yeah. You can pick anything you want that's lower than 0. Can you pick anything higher than 0? Yeah, you can do that. So that's what the answer looks like as a number line. That's everything except 0. What would that be as an inequality? Well, you can pick anything that's lower than 0, or you can pick anything that's higher than 0. That's how you write what the domain is. This is writing what it isn't. Okay, a lot of times they want to know what it is. It's anything that's lower than 0, and it's anything that's higher than 0, but not 0. So there is your domain.
Is that circle not colored in?
That'd be like an open circle. Yeah. That would not be filled in. Because if you fill it in, now you're saying you can equal 0, and now you've basically just shaded the whole number line. But 0, there's a circle there. Yep.
Do you have to do the x is less than 0 or x is greater than 0, or with the x is not equal to 0 at the top suffice?
So if the directions said to write your answer as, if the directions said write what the domain is, then you want the bottom one.
Okay.
If they just say what values are not in the domain, then you could do the top one. So it depends on the wording.
Also, can you divide it into x's less than 0 and zeros is less than x?
So the only statements that you can combine together, like when you put an x in the middle and then you put like inequalities on each side like that, are when it's the word and. This is technically not an and. You can either pick a number here or you can pick a number here. And means you could pick a number that would be in both of these at the same time. That's not possible. A number can't be less than 0 and greater than 0 at the same time. So it's a good question, but yeah, you can only combine these when it's an and. So you do have to write it like that every time. There's no short way to write that.
Is there a way to write that interval, or
Different than what I wrote here.
like in like the how it's called interval with the brackets and stuff?
Oh, to write it as an interval? Oh yeah, absolutely. So if you want to write it as an interval, think of this first part. Let's call that interval 1. What's the lowest number in interval 1?
Negative infinity.
Negative infinity. Up to. And what's the highest number in interval 1?
0.
0, but we don't include it. So negative infinity to 0. Or, now look at interval number 2. What's the lowest number in interval 2? 0, but we don't include it. And then what's the highest number in interval 2? Infinity. Yep. So you can write it in interval notation just like that. It means exactly the same thing. Okay, let's graph it and see if we can figure out the range. I think we've done absolute value. If you don't remember though, it's math, number, and then it's the first option. It says ABS. So put in absolute value of x, and then put divided by x. Let's do zoom 6. And that's what your graph looks like. Should have gotten a picture that looks something like this. And the reason you get that is because no matter what you plug in for x, you only get one of two answers. If you plug in a positive number, like 5. What's the absolute value of 5 divided by 5? 1. What if you plug in 7? What's the absolute value of 7 divided by 7? 1. I could keep saying positive numbers. You're just going to keep getting 1. Now try a negative number. Let's say you plug in negative 2. What's the absolute value of negative 2? 2. And then divided by negative 2. That's negative 1. So the range in this problem, it's kind of special. There's only 2 numbers that are in the range. When you can actually list every single number that's in the range, this is how we do it. You don't have to use interval notation. Well, you can't use interval notation because interval notation, you give a low value, a high value, and then it's everything in between. No, it's not everything in between negative 1 and 1. It's just negative 1 and 1. Just those 2 numbers. So to do that, you're going to write it like this. So range. We'll put this symbol. It's like a curved bracket. I don't really do a good job drawing it. I guess it should look more like that. And the range in this case is the number negative 1 and the number 1. What goes between these brackets is a bunch of numbers separated with commas. As many numbers that are in the range as you need to list. And in this case, there's only 2. We don't do that with interval notation because you can't. I mean, if I said to you to write every number that's less than 0, that's impossible. I mean, negative 1, negative 2, negative 2.4, negative 2.67419. I mean, you can't write them all. So that's why we have to use an interval. Okay? But that's called a set. It's just the 2 numbers, negative 1 and 1. That's the set of numbers. Okay. Any question on it? Okay, so let's look at composition. So composition is when we take functions and we combine them together in a little bit different way. And the basic idea of composition, the simplest way I can say it, is you're plugging one function into another. That's composition. You're plugging one function into another. Normally, we plug a number into a function. Well, you're plugging a function into a function. That's composition. And we'll try it with these 2. So what's the question going to look like when it asks you to do composition? It's usually going to say something like this. Find G, and remember a left parenthesis is pronounced as of in this case. G of f of x. People remember that after seeing that now? Yeah. Things like that? That's composition. Now, you can do G of f or you can do f of g. They're usually different answers. We'll try both. So if the direction said to do like G, actually, do I do this? Let me see if I do this in a second. Let's say the direction said to do G of 9. Well, what that means to do is take 9, plug it in for the letter in function G. So I would take the 9, and I would plug that in for x, and the answer to the square root of 9 would be 3. That's plugging a number in for the letter. Well, what we're going to do is we're going to plug a formula in for the letter. That's the way we're going to do it this time. So the way I write it down is I write G of, and now it says f of x. So I'm going to look up what f of x is. F of x is x squared plus 3. So the first step, I just replaced this with what the problem tells me f of x is. Now, in function g, everywhere you see a variable, replace it with not a 9, but replace it with x squared plus 3. So can anyone think they can tell me what that's going to look like if you take function g and then replace the letter with what's in those parentheses.
The new function would be, doesn't matter what the letter is?
Yes.
Oh, so g of x would be the square root of x squared plus 3?
Right. It's the square root of x squared plus 3. You took x squared plus 3 and you filled it in for x. And no, that square and square root do not cancel. When you have plus or minus under the root, it messes that up. If you just have this, then sure. Square and square root cancel out. But once you put like a plus 3 here, you can't. So that's as simple as it gets. Okay, so that's g of f. Now let's try it the other way. F of g of x. So that's f of, and now look up what the formula is for g of x. Okay, what's my formula for g of x? Square root of x. So now in the f formula, everywhere you see a variable, you're going to replace it with square root of x. Now if you can simplify it, I don't want to yet, we'll do that in the next step. But I just want you to look at the f formula and change the variable to square root of x. What would you get if you did that? Yep.
The square root of x squared plus 3.
Right. You're taking this and you are filling it in for that right there. You would have the square root of x squared plus 3. So this would be the square root of x squared plus 3. Now, is there anything there that simplifies?
Yes.
Yeah, what simplifies?
You can just write it as x
X
plus 3.
plus 3. Now, when we find the domain, I'm going to talk about it in a second. You might look at that final answer and say, well, it doesn't have any square roots in it. It doesn't have any fractions in it. So I can take any number and plug it in for x. Well, you have to remember where this came from, though. It came from something with a square root. And that's important. So just because the square root canceled out doesn't mean that it wasn't there at one point. And we gotta go back and look at that. And I'll show you how to do that. So this is just a different way. I'm not going to ever write a question like this on the test, but if you see it in the book, if you see this symbol like G, and then you see a circle and then an F, it means this. That's the way I've been writing it. Again, on the right is the notation you're always going to see on the test. But you might see that G with a circle and then an F in the homework. It's just a different notation. I don't particularly like it. I mean, it is a little shorter, I guess, but I like to write all the parentheses so then I can see what I'm doing. It's up to you. Okay, so how do you find the domain if you compose two functions? It's not quite the overlap. It's not quite like what we said before. And the way I think of the domain when I have to do composition is in my head, I start with all real numbers. I say, okay, so I'm going to start with that, and then I'm going to kind of filter things out, or I'm going to eliminate things. And the first thing you do is if you start with all real numbers, eliminate any values that are not in the domain of the inside function. Okay, what do I mean by inside function? When you do a composition, there's an inside function and there's an outside function. The inside function is the one that's inside parentheses. The outside function is the one that has the letter in front. Okay, that's the outside. So you start with your inside function, and you get rid of any values that wouldn't be in the domain of that. Okay. So what are you looking for? Two things. You're looking for any square roots, and you're looking for divide by 0 in the inside function. After we look at the inside function, then what we want to do is look at the final answer. Okay, so what's the final answer? The final answer is what I just circled right there. It's what's in the box, x plus 3. Or in this case, the square root of x squared plus 3. So look at that final answer, and then eliminate any values that wouldn't work there. So if the final answer was x plus 3, I would say there are no additional values to eliminate there, because the final answer doesn't have a square root. And it doesn't have a fraction. Okay, so we start by eliminating any values that don't work in the inside function, and then eliminate any values that wouldn't work in the final answer. And what you're left with is the domain. We'll try a few examples of that. Range isn't really going to be that hard because range, we're just going to graph it on the calculator, and I can show you how to use the calculator to help you. Right, let's try, before we do one with domain, let's actually just try plugging in a number. It's actually kind of like the one I showed you earlier. And make sure we know how to do that. So when you want to plug in a number, you start on the inside and you work your way out. G of 9. If I take 9 and plug it into function g, I would have this. Square root of 9. And the square root of 9 is what number? 3. So when you find g of 9, you get 3. Now you plug 3 into function f. So if you plug in 3 for x in function f, what would you get for a final answer? 4. So that's composition. That's just using a number to do it. That's the same idea with letters. Is there any question on the number? All right, then let's try f of g of x. So I like to write f of, and then fill in what g of x is. What's g of x? Yep, it's the square root of x. Now, in function f, replace all the variables with square root of x. And what would you get?
Square root of x plus 1.
Yeah, you'd get square root of x. Specifically, the plus 1 is on the end. That's like a vertical shift up 1. Any question on the f of g? Yeah.
Why did you? Is that a different problem or the same problem?
So it's using these two formulas.
Okay.
So it's still using the same two formulas. It
But
is
it's
a different
separate
question.
from before.
It's a separate question from the top one. Yeah.
Okay.
It has nothing to do with the top one. But they all have to do with these two formulas. Okay. How about the other way? G of f of x. What's f of x? X plus 1. So now in function g, replace every variable with an x plus 1. What would you get if you did that? Yep.
Square root of x plus 1.
So same thing I got right here?
No, different. The square root would be over the whole thing.
Yeah, it's the whole thing. So this is more like a horizontal shift, left 1 unit. That's a vertical shift, up 1 unit. So it is different. But that's f of g and g of f. Okay, let's try one now where we do the domain. I don't want to do it both ways. I just want to do the second way. So let's find f of g of x. Okay, same idea. F of, what are we going to replace inside the parentheses here? It's going to take the place of g of x.
Square root of x.
Yep, we're going to put in square root of x. And now, you're going to take that square root of x and plug it into f. Don't simplify it if you can. There's a reason why I don't want to. Just tell me, what would you get when you plug square root of x into f? Yep.
Parentheses, the square root of x squared
Okay,
minus 1.
minus 1. Now I want to simplify it. What would the final answer be?
X minus 1.
Okay. So this time, I want to know the domain. Okay. To find the domain, the first step is look at the inside function and eliminate any values from that. In this case, the inside function is g of x. G of x is a square root, so there are only certain values we can use. What's the domain of this inside function? Square root of x. You can only plug numbers in for square root of x that start at what?
0.
And go to what?
Positive infinity.
Positive infinity. So the domain of this inside function is 0 to infinity. Can't plug in negatives. Now, look at the final answer. We have to see, are there any more values we need to eliminate? So we've already eliminated any number that's a negative. Is there more? Well, does the final answer have a square root in it? No. Does the final answer have a fraction with a variable on the bottom? No. Then part 2 of finding the domain doesn't apply to this problem. When you look at the final answer, there are no additional values to exclude. So the only exclusion we had to make was from step 1. And so my domain comes completely from step 1 in this problem. So the domain is 0 to infinity. Now, if you want to find the range, which we're going to do range in a second, which one do you think I would want to plug into the calculator? What's in the red box or what's in the black box? The red box. If you plug in the black one and you just tell the calculator x minus 1, it would have no idea that there was a square root in that problem originally. It wouldn't know. But if you plug in what's in the red box, then it would know. So if you type in, just like I have, in parentheses, the square root of x squared minus 1, it's going to draw this graph, but it's only going to start at 0 and go up to infinity. See? Starts at 0. If you typed in the second version, x minus 1, this would just be a line instead of a ray. Okay? It would draw the line in both directions. And that's not what this one really looks like. That's what it should look like. So my advice is whenever you have to type something in on the calculator, like a square and a square root, if they cancel, type it in on the calculator, not canceled. And then the calculator will cancel it itself, and it knows not to use negative numbers. Again, compared to doing this, Now the calculator doesn't know it shouldn't use negative numbers, and it just draws the whole line. That's not right. Okay, so range. So range, really, I'm just going to put use the calculator. So that's just pretty much what we do. Okay, so we'll find the domain, and then we use the calculator. Is it still important to know the domain? Yes, because if you need to set a certain domain, that's the window. So if you're supposed to be looking at a certain values, like from 0 and up, you shouldn't be setting your x min to like -10. It said 0 and up in the domain. So you really have to find the domain first and then use the calculator.
So will we just show that, like, if we had, like, find the range and like something like this, would we just, like, show the graph that it looks like, or would we, like, what would we write?
So yeah, you would just find the domain first, you'd put it in on the calculator, and then for the range, you would just write, like, you know, bracket, a number, and then parenthesis, infinity.
And when it's infinity, is it always a parenthesis?
Yep, always. Okay, again, I don't want to do this one both ways. Let's do, well, you tell me. You want to do the first or the second? Second. Okay. So we're going to find f of g of x. F of g of x. Okay, start with the inside. What's g of x? X minus 3. Now, in function f, anywhere you see a letter, replace it with x minus 3. So what's the final answer going to be? Square root of x minus 3. Whole thing is under the square root. I should have asked you that. But. Okay, find the domain. 2 steps. Yep.
So the numbers on the left side of the equal sign, do they not really like matter?
The numbers. Can you show me what number?
So in the far right, there's just the square root of the x minus 3, but the x minus 3 to the left of them doesn't like mean anything.
This?
Yeah.
So that's just like an intermediate step to get the final answer. So I'm just showing the work of how to get that.
Okay.
So the final answer is what's in the box.
Why are we just not writing the f, or does it go away? Because I thought like f was meant to be like y.
It's just, he's not writing the f out. He just wrote f instead of doing.
Okay. But it's
Yeah, I don't use y here because I have 2 things that are y. F of x is like a y and g of x is like a y, but I need to distinguish them.
okay.
I mean, so that's why we use the f and the g.
Like,
It's like different colors.
the f is on the outside, right? So you put that in the f over there. So that's why
Okay, now to find the domain, start with the inside function and ask yourself, are there any restrictions on g of x? G of x is x minus 3. Are there any square roots in x minus 3? Are there any fractions with letters in the bottom? No. Then from the first part, we don't get any values that need to be eliminated. So the domain is still all real numbers for now. But we have to look at the second part. Look at the final answer and see if there's anything we need to eliminate. Does the final answer have a fraction with a variable in the bottom?
No.
No. Does it have a square root?
Yes.
Yes. Then there are values we need to eliminate. Not from the inside function, but from the final answer. I think we did this earlier already. What values could you pick for x? That would work here. Yeah?
I have a question, but I can also, it's 3 is what you can pick.
3 is okay to pick.
It is?
Yes, because if you plug in 3, you'd have the square root of 0, and that's fine.
Oh, okay.
You can't divide by 0, but you can take the square root of 0. So 3 is the...
negatives, right?
Right, you can't take the square root of a negative. So 3 is the lowest number you can pick.
Also, for the f in the beginning, I know that you put in for x, but why is the -3 considered under the square root as well?
Because you're taking this whole thing
Okay.
and replacing that whole thing.
Okay. All right.
If you did it the other way, the 3 would not be underneath.
Okay.
So I still need to finish my domain though. 3 is the lowest value. What's the highest value? Yeah? Infinity. We need a parenthesis there, and we need a bracket there. That's your domain. Range. So range, I said that's where we use the calculator. So there's nothing I have to worry about plugging in that's going to cancel. Nothing canceled like square and square root. So you can type in the final answer. Square root of x minus 3. Okay, so square root x minus 3. And remember, range, we're looking for how high and low the graph goes. We already know the graph is going to start at 3 and go to the right. That's the domain, left and right. Range is up and down. So what does it look like the lowest that graph goes is?
0.
And the highest? Infinity. Yep. It'll just keep going up. We never reach infinity. Do we reach 0?
Yes.
Yeah. In fact, if you plug in the number 3, 3 minus 3 is 0, and the square root of 0 is 0. So that's your domain and range. From 3 to the right, and from 0 up. Question on that? Okay, I think this is the, yep, last. Okay. So I'm going to summarize all the transformations that we learned yesterday, except I'm going to summarize them to not just a parabola, but to any function. So I'm going to use some letters, like we used A yesterday to represent stretching, H and K. If you remember, that was the vertex. These are real numbers. A, H, and K can be positives, negatives, fractions, decimals, or 0. So yesterday, you would have had something like this. A 3, and then an x squared. That would have been the function. So we multiplied by a number in front. What I'm saying here is it doesn't matter what you put for this. You could do this. And the answer is still the same type of transformation. What happens when you multiply by a number in front? That causes what kind of transformation? Yeah?
Vertical stretch.
Yes. Or compression. If it's a fraction, it would be a compression. How about adding or subtracting a number on the end? Yesterday, you would have seen something like this. But what I'm saying now is it can be anything you want there with a +2 or +3 or +4. What does plus on the end do to a function? Not left. This is outside the parentheses. Yep. Vertical shift. Plus is up and minus down. So I put them in that order. Up is plus, minus is down. The next one I broke it out because it's a little more complicated. If you have a plus inside the parentheses, what does that do? Plus would shift it to the left. And a minus would shift it to the right. And yesterday, it would have looked something like x squared, or it would look like x minus 3 squared. You could do it for like a square root function. In fact, we saw something like that today. If you put the -3 inside the parentheses or inside the symbol, it's always shifting left or right. When you put the plus or minus outside the parentheses or outside the symbol, that's going to shift up or down. Okay, we have negatives. What did we say yesterday that the negative causes the graph to do?
What was the word? Reflect.
Yeah, that's a reflection. If you put the negative in front, does anybody remember what kind of reflection that is? Versus inside. This is the one I showed you first yesterday with a parabola, but you couldn't tell because it's symmetrical. But the negative in front yesterday, you could tell with a parabola. Yep.
In front of it is over the x-axis.
Yep, that's a vertical reflection, or it's over the x-axis, exactly. And when you put the negative on the inside, that's reflecting over the y-axis. So that's a good chart that summarizes all the different transformations. And it's just not for parabolas, it's every function we're going to study all year. Trig functions, square roots, radicals, rationals, all of them. Okay. That's 1.6. Okay, I'm gonna put up the homework, but like I did yesterday, I am going to I got to adjust it. Okay, so 1, 2, 3, that's okay. 6 and 8, that's okay. 13, 15. So we're gonna skip 32. We're gonna skip 44. And you want to skip one more?
Yeah, I'll play 63.
Okay.
Thank you.
You want to skip more? No.
No.